Okay, lots of ways to graph parabolas, and we're just going to touch the surface for our purposes, and we're going to focus on plotting points. So let's talk about what a parabola is. First of all, a parabola results when you have y equals some degree 2 polynomial, okay? Usually in terms of x. And if you have a graph or an equation like that, degree 2 means it's quadratic in this variable. The graph is going to be a parabola, which means it's a U shape like this that opens up or it opens down somewhere. And a couple nice features of a parabola are they always have this peak, this vertex is what it's called. And they're always symmetrical across this vertex. So if you get a point on one side of the vertex, you don't have to calculate a point on the other side. You can just graph it because you know it's symmetric. Okay. So let's do some examples. Actually, let me mention something first before we get started. Like, how do you locate this vertex? Um, this goes beyond plotting points. So if you find it useful and it's pretty easy to remember, then use it. If not, just plot points. But it's certainly worth mentioning for those that are interested. Um, so if we have an equation like y equals ax squared plus bx plus c. So that's our degree 2 polynomial, right? And it's written in this particular form where the coefficient of x squared is a, the coefficient of x is b, and the constant is called c. Then the vertex occurs at, and this looks a lot like the quadratic formula. It tells us where the x value where the vertex is. X equals, remember the quadratic formula is a fraction, negative b, and then plus or minus the square root. Just ignore that for this vertex formula. And then on bottom, you've got the over 2a. So instead of having the plus or minus the square root stuff in the quadratic formula, you just have the negative b over 2a. And I'm not getting into why that's true. The plus or minus arises from the symmetry, and the vertex is the point where you don't have a symmetric point. That's the idea very vaguely. But this is what we call the vertex formula and establishes a quick way to locate where that vertex is going to occur. So I'll try to mention that as we do the examples, but you can certainly just plot points. All right, so first example, let's graph y equals x squared plus 2x. And we know this is a parabola because this is degree 2 on the right side. So I'm going to go ahead and find the vertex. So I know the vertex is going to happen at x equals negative 2 over, so that's negative b over 2 times 1, which is 2. So the vertex is going to occur x equals negative 1. So when I set up my xy table, I know I want to plug negative 1 in for x. And if I plug negative 1 in for x, I get y equals negative 1 squared, which is 1, plus 2 times negative 1, that's negative 2. So I know my vertex is going to occur at negative 1, negative 1. Now what I'm going to do here is actually just plot x values bigger than negative 1 now. I'll show you how that will work in the graph. Let's plug in 0. If we plug in 0 for x, what we're doing is calculating the y-intercept. So if x is 0, y would be 0 squared plus 2 times 0. That's simple. That's 0. Let's plug in 1 for x. Y would be 1 squared, which is 1, plus 2 times 1 is 2, so that would give us 3. Let's do one more point. If x is 2, y would be 4 plus 4, which is 8. Let me set up my grid real quick. And let's get to plotting some points. So negative 1 should be the vertex. Then we've got 0, 0, 1, 3, and then 2, 5, 6, 7, 8. So you can see this is the right side of my parabola. And because this is the vertex, I know that across this axis of symmetry, I'm going to get points that are symmetric. And so rather than actually putting those in my XY table, I'm just using the symmetry to get the rest of my graph. And so here's the parabola for this quadratic equation in X. Let's do a couple more. Let's graph y equals 2x squared minus 4x plus 3. And so for my vertex, I get x equals negative b, which is positive 4, over 2a. 2 times 2 is 4. So my vertex is going to occur at x equals 1. So I'll plug in 1 for x. So y is going to be 2 times 1 squared. 1 squared is 1 times 2 is 2. Minus 4 times 1, so that's minus 4 plus 3. So I get negative 2 plus 3, which is 1. So there's our vertex. Now let's plug in numbers bigger than 1, like 2. 2 squared is 4, times 2 is 8. Minus 4 times 2, so that's minus 8 plus 3. That just turns into 3. Let's plug in one more. Let's plug in 3. If x is 3, we get 3 squared is 9, times 2 is 18, minus 4 times 3, so that's minus 12, plus 3. So we get 6 plus 3, which is 9. We could keep going, but let's go ahead and set up our grid. This time I set up my grid a little bit differently. I used a different scale on the x-axis from what I used on the y-axis, just to let you know that as long as your x-axis is entirely consistent and your y-axis is entirely consistent, you're good to go. So let's plot the point 1, 1. That's my vertex. So 1 on the x and 1 on the y would be there. 2, 3 would be here. And 3, 9 would be up here. So this is the right side of my parabola because 1, 1's my vertex. I can plot symmetric points. Let's see here. I think that would be over here. No, I went too far. It's harder to do this on a tablet than you might suspect. Yeah, there we go. And there's our parabola. Now this is the vertex is supposed to be a point, a smooth point. You know, it shouldn't be sharp. This looks a little too sharp, but again, I'm doing the best I can with the tablet. So that's another example of graphing a parabola. I've got two more coming up for you. Let's try to graph y equals negative x squared plus 7. And so if we want to find the vertex here, notice that there's no x term, which we need to find our b. So you might think of this as like negative 1x squared plus 0x plus 7, so that you can see that a is negative 1, b is 0, and c is 7. So our vertex now would be x equals negative 0, which is 0, over 2 times negative 1, which is negative 2. So the vertex here occurs when x is 0. So we'll plug in 0 for x. Negative 0 squared is 0, plus 7 is 7. Let's plug in 1 for x. We get 1 squared is 1. Negative 1 plus 7 is 6. We'll plug in 2. 2 squared is 4. We have negative 4 plus 7 is 3. By the way, I hope you're catching on to the order of operations here. You're squaring before you multiply by the negative. If that's not something you're totally comfortable with, certainly make a note of it. Okay. Let's plot these points, see what we come up with, and we can do some more if we need to. Okay, so our vertex is at 0, 7. Our next point is at 1, 6, and then we got 2, 3. So this time our parabola is opening downward like this, And we can use the symmetry to plot a couple more points here to finish out the left-hand side. So this parabola opens downward, and the reason that is because the a coefficient here is negative. That's always going to be a hint to you that your parabola should open downward. Okay, last example, just to be thorough. We have y equals negative 2x squared minus 8x plus 6. Our vertex will come from x equals negative 8, which is positive 8, over 2 times negative 2, which is negative 4. So our vertex is going to occur when x is negative 2. So our vertex, x is negative 2. We need to find the y with it. So again, order of operations, negative 2 squared is positive 4 times negative 2 is negative 8 minus 8 times negative 2, which is negative 16. So minus negative 16 is plus 16 plus 6. So we get positive 8 plus 6, which is 14. So our vertex is negative 2 comma 14. Let's plug in negative 1. Negative 1 squared is 1 times negative 2 is negative 2. Minus 8 times negative 1, so that'd be minus negative 8, which is plus 8 plus 6. So 6 plus 6 is 12. Let's plug in 0. That's always like to plug 0 in. We get 0 minus 0 plus 6. So that's just 6. So this time I have to be a little mindful in setting up my graph. My parabola should open downward. So 14 will be my highest y value. It should go down from there. So let's see here. Let's how do we want to set it up this time? It's actually going to be pretty high on my graph. I'll mark every 5 units on the y-axis. So 1, 2, 3, 4. There's 5, 10, and 15. And then on my x-axis, I'm just going over to like negative 2. Yeah, so let's see. We'll call this negative 1, negative 2, negative 3, negative 4, and we'll list more as we need to. Okay, so negative 2, 14 is my vertex. That is up here. Negative 1, 12 is right here. 0, 6 is right there. So the right side of my parabola looks something like this. And here's my axis of symmetry. So if I'm mirroring those points, it should look something like this. And there is our final parabola. I hope you catch on to the vertex. I think it's useful to know the negative b over 2a. Understand that sometimes you'll get fractions there, and you might use a calculator when you plug them in to get the output or the y value. Or you could just plot a bunch of points and see if you can start to identify where the vertex occurs, because that's a critical component of a parabola. If you plot points and you get a graph that looks just like this, well, you probably need to keep plotting more points to the left to find out where it rebounds and comes back down. Okay, so anyway, I hope you found this useful, and good luck as you practice.